In this tutorial, we will build and host an application on DKubeX 2.0 using a coding agent, and then use it entirely from your workspace, with no separate hosting setup. The app we will build extracts data from documents. It takes a PDF and pulls out the fields you define, using a vision model. Let's build it. In your DKubeX 2.0 workspace, open Claude Code. Now we give it a single prompt. Build a DKubeX app that extracts data from documents, following the specification in the prompt file. Alongside the spec, we point Claude Code at the dkubex-app skill. This is the platform's own knowledge for building and hosting on DKubeX 2.0. It teaches the agent to allocate a port, configure routing, and publish the finished app as its own tile in the workspace, with no Docker, no pipelines, and no manual deployment. And it works with any coding agent in the workspace, whether that is Claude Code, Codex, Copilot, or anything else. We run the prompt, and Claude Code gets to work, reading the specification and building the application. So what is inside that specification? It is the complete blueprint for the app. Let's walk through it, one section at a time. First, the core workflow: configure a vision model, upload a PDF, define the fields you want, run the extraction, review the results, and download them. The tech stack: a React and TypeScript front-end, a fast API backend, and PyMupDFV for reading the documents. The application has two pages, Settings and Document Extraction, and it opens on Settings, so the model is configured first. The extraction page itself: a PDF preview on one side, the fields and results on the other. Upload is drag and drop, and it accepts PDFs only, rejecting anything else. Every uploaded document gets a live, page-by-page preview. The user defines their own fields, each with a name, a description, a data type, and whether it is required. Optional instructions set the guardrails, for example, extract only what is present, and return null when a field cannot be found. The extract document action validates everything first, then shows clear progress as it runs. The vision model sits behind a clean provider interface, so any OpenAI-compatible model works, with no model-specific logic anywhere else. Every page is rendered to an image and sent to the model, and page numbers are preserved, so multi-page documents are fully supported. A dynamic prompt asks only for the requested fields, and returns structured JSON with a value, a confidence score, a page, and the supporting evidence for each. Results are shown in a clean table, with low confidence and not found values called out clearly. Where the model provides it, the exact source evidence for each value is shown. Results can be copied, downloaded as JSON or CSV, run again, or cleared. The settings page configures the provider, the base URL, the API key, and the model, with a Fetch Models button and a test connection check. Security is built in, API keys are masked and never logged, document contents are never stored, and settings are saved with lockdown permissions. A clean set of API endpoints covers health, settings, document upload, and extraction. Every failure mode is handled with a friendly message, from an invalid PDF to a model timeout, and never a stack trace. It runs locally without Docker, with the key settings driven by environment variables. Testing needs no real API key, using synthetic PDFs and mocked model responses across the whole stack. Structured logging tracks each operation without ever recording keys or document contents, and a concise README ships with it. And finally, it builds the real, working application, runs all the checks, and verifies the full workflow end-to-end. As we have been reading, Claude Code has been building. It takes only a few minutes. Once the build finishes, the app is ready, built, tested, and running on your cluster. To open it, we go to the DKubeX 2.0 apps page, and there it is, our new document extraction app, published as its own tile. We click it to open. This is the finished application, running on your own DKubeX 2.0 cluster. Because the model is configured first, we open Settings. Set the provider to DKubeX, SecureLLM, and the base URL is filled in for you, ending in /SecureLLM/v1. That is the governed gateway in front of every model on your cluster. Add your DKubeX Workspace API key, click Fetch Models, and the app lists every model available to your key. Select the deployed vision model, run test connection, connection successful, and save settings. Now, the workflow. On the document extraction page, upload a PDF, here a loan estimate, and the app renders a live preview. Then define the fields to extract: loan ID, loan amount, applicants, and interest rate, each with a name and a data type. You can also add instructions the model must follow, for example, extract only what is present and return null where a field cannot be found. Click Extract Document. The vision model reads every page and returns structured results: loan amount, applicants, and interest rate, each with a confidence score and the page it was found on. And where the document had no loan ID, it reports that precisely, not found, rather than inventing a value. The results can be copied or downloaded as JSON or CSV, and every one of those calls is governed. SecureLLM is the AI gateway on DKubeX 2.0. Every model on the cluster sits behind it, so every request and every response flows through a single governed path. Which means it is all captured. Open the usage logs, and every request the application made is recorded here. Select one, and you see the metrics, status, input and output tokens, and latency, along with the provider and the model that served it. Open the messages, and you see the exact exchange, the system prompt, the fields we defined, and the structured response the model returned. Nothing is hidden. Every call your application makes is logged, governed, and yours to audit. And that is it. From a single prompt, a coding agent built the application, and the DKubeX app skill published it as its own tile, running on your DKubeX 2.0 cluster, ready to use.